Hi, my name is Kristen Kinsevich, and I'm a PhD student at Regent University. This video is going to be about running an ANCOVA, and I'm going to be following the textbook Using Multivariate Statistics by Barbara Tabachnick and Fidell. I have the 5th edition, so if I reference page numbers, that will be the edition I'm talking about. I'll try to reference the section numbers as well in case you have a different edition. Now, the data set that we're going to use for this can be found here at this website. And if you don't already have the data set provided to you, then you can go ahead and type that in. And the file is this one right here, ancova.sav. So I have already gotten that, and I'm going to go ahead and open it up. And we'll see here that the variables that we have, there's this one subject number, which will not be important in this assignment. And at drug is the attitudes towards the use of medication. PHY heal is about physical health symptoms. MEN heal is mental health symptoms. PSY drug is the use of psychotropic medications. Employment, and then religion. Now, in this assignment or this exercise, which begins on page 223 for me, it's section 6.6 of the textbook. It's a complete example of analysis of covariance. It's going to run through everything that we need to do. And if you read that first paragraph, you'll see that the thing that they're going to be looking at in this example is the association or the relationship between the attitude towards medication, this at drug variable right here. That's going to be our dependent variable. And our independent variables are employment and religion. Now, you might look at these variables and wonder something else. I kind of wondered what the connection was between physical health and mental health and the use of medications with the attitudes towards medications and all that. But ANCOVA is not your test if you want to play around with that, because the independent variables need to be categorical, and then the dependent variable is non-categorical or continuous. So we're going to follow along exactly with the book. And so the research question, the main research question would be, are attitudes toward medication associated with current employment status and or religious affiliation? And that's pretty much exactly how the book phrases it as well. The and or is important because we're going to be looking at, does employment factor in to the attitudes towards medication? Does religion factor in to the attitudes towards medication? And combined, is there an interaction effect between employment and religion and attitude towards medication? Now, if you go into the variable view, you can see that the employment variable has 2 values. You can click on them here, employed or unemployed. So there's 2 levels of that variable. And then in religion, if we click on that, there's 4 levels of this one, which you'll notice in the degrees of freedom. That would be 3 degrees of freedom because there's 3 choices more than just 1. So there's, for religion, none or other, Catholic, Protestant, and Jewish. So we go back to data view, and first what we're going to do is we're going to want to test some assumptions of the ANCOVA. And you can find the list of what we're going to do exactly in order of how we're going to do it on page 238 in the 5th edition, which is table 6.26, checklist for analysis of covariance. And so the first thing we're going to start with is looking for unequal n and missing data. So let's start with the missing data. Now, I could go through, there's 465 cases. I could kind of manually flip through and try to look for missing data, but I might miss something. There's a lot of cells here. So I'm just going to quickly go to Analyze, Descriptive Statistics, Frequencies. And I'm going to just look at our initial variables here. Oops, I'll get to the covariates in a minute, but the variables of attitude towards the use of medication, employment, and religious affiliation, we want to just kind of see if there's anything missing there. Now, the other variables we are going to need, and so we might as well include them here, but I didn't mention them yet, so let me pause and say physical health symptoms, mental health symptoms, and the use of psychotropic drugs are going to be included in our analysis as covariates, which means they're not part of our main research question that we just talked about. We want to know if employment status or religion is related at all, or if attitude towards medication is related at all to the employment status or to the religious affiliation. But we also want to see if any of these covariates might apply. And the reason they're covariates is because we don't think that physical health symptoms might cause an attitude towards the use of drugs. ANCOVA is not going to give us a causation, even with the independent variables. But we might say, are they co-occurring? Because these employment status or religious affiliation are kind of, again, they're categorical, they're a status, and so that would be a difference than physical health symptoms, mental health symptoms, or the use of medications. Those would be things that, are not quite the same. They're not categorical. And so, again, we're just looking at them as covariates. So we're choosing all these variables, and we're just looking right now to see if there's any missing data. So we shouldn't need to select a whole bunch of things, even things like mean, standard deviation, all that stuff. We're going to do that in a minute because we're going to group these into categories. But for now, we're just looking for missing data, and so we don't really need a whole lot. We don't need histograms or anything like that because we are actually not looking for normal distribution of the data. What we're going to talk about when we get to normality is sampling normality. And so you don't need any of the histograms that you might normally want in other kinds of tests. And so let's go ahead, and all we really want is this display frequency table. So let's go ahead and click OK. And here is where basically this very first chart is kind of all we need because we're just looking for missing data right now. And we see that there's no missing data in any of the variables except for religious affiliation, which they do mention in the book. So that confirms that we are right. And it shows the frequency tables, which could help with the outliers later on. So we might come back to that. But ultimately, right now, the step we're looking for is just this missing data here. Now, the reason that's important is because in an ANCOVA, if you have different numbers within each group, it is complicated. And so the 3 missing data would throw off anything that has to do with religious affiliation. And that's because some groups, if you're dividing up the religious affiliation groups, there might be some groups with one more than another group. And so that would throw off your comparison. So basically what we now need to do is eliminate these 3 from our study so that all of them are just at 462. So that will be our N, or the number of participants we're actually going to include in the analysis. So let's go ahead and save our output just to not forget to do that. And I'm going to have to call it something. I'll just call it output 1 ANCOVA. And I'll hit save. Okay, so that we'll keep adding to that. But for now, what we need to go back and do is we have this religion. Let's go ahead and sort. If we right click, we can sort ascending. Boom, there we go. These are the 3, 1, 2, 3 missing data. Now what I'm going to do, and this might be different from what the book chose to do, but I'm just going to replace those with zeros to make my life easier. And I am now going to go Data, Select Cases, and we're going to say if the religious affiliation is greater than 0, then we want it included. So we'll hit Continue and OK. And the output just tells us that we had sorted the cases, and now we went and replaced that. So let's go back to our data set. And here we go. We have another little variable that's the filter. That's just following our instructions. And you'll see over here, there's 3 little slashes. That means that those cases are now eliminated. And so we're not including them anymore. So again, we'll just save that change on our data set. If you close this and come back to it, you will have to do that step again. This part will stay and this variable will stay, but you will have to just go in and do data, select cases, wherever that went, down here. You'll have to do that again because it doesn't save that. So these slashes won't be there if you close it and open it again. So if you come back to this later, make sure you do that step again. Okay, so now we've taken care of the missing data, and now we want to just make sure that everything else is okay with our cell sizes, and we want to be able to start analyzing this in groups. And the book may have actually kind of done this step in order to find the missing data, but I found that to be a little more confusing. So I did the frequency table first. But now what we're going to do is we're going to go to Data, Split File, because what we want is we want to compare 8 different groups. In this case, this study was about women. We want to compare 8 groups of women because we have 2 levels of employment, which is one of our independent variables. They're either employed or unemployed, as we saw. And then there are 4 levels of the religious affiliation, and that is the none or other, Catholic, Protestant, and Jewish. And so it's called a 2x4 ANCOVA because it's 2 levels by 4 levels. And so that makes 8 groups. And we want to organize our output by those groups. And so we click on this little button here, Organize Output by Groups. And we're going to go ahead and put religious affiliation first. The book mentioned kind of putting that one first, although I kept doing that in various things, and I'm not sure it necessarily made a difference, but I'm trying to follow what they said. And so there's current employment. So first it's going to look at religious affiliation and then employment status. I think the reason that makes sense is when you see your output, actually, it lists none or other employed, none or other unemployed, Catholic, employed, Catholic, unemployed. And so that is the way that we want to understand our groups. And so we will go ahead and click OK. And again, the only output you're just going to see here is that you split the file and separated by religion and employment. Now, the book uses SAS as a statistical package, and so I'm using SPSS. And so this will be slightly different than the description or the syntax that you'll see. And so the split file is necessary in SPSS. So I went ahead and saved again, just keep hitting save. And then I'll minimize this. And now nothing has changed on these variables here, but now when I analyze the data, it will be in those categories until I change it. So now again, if you close this and come back to it, you might need to do that step again. I'm not sure about that. So now we need to compare means. That's when the book talks about using the SAS means. In SPSS, what we would do is analyze, compare means, and just this top one here, means. Now, this is going to give us some interesting information on our dependent variable. And so we're looking there. And then I am trying to remember Because it is sorted by current employment and religious affiliation, I think that the independent list is actually the covariates in this case. So I'm hoping that I'm remembering that correctly. If not, we will learn together and try it again, but I got this right before. And so I believe that those are independent, and in this case, it doesn't mean they're the independent variables, but perhaps we're looking at them individually. We'll see. We may have to redo this part. The options, you want to click options here. If we want to match the book, which is the output that's table 6.12, then what we need to do is click on the things that they have. And I would like them in the order that they have them. Again, you could have just skipped our first step with the missing data. You could have found it this way, but I'm just clearing this out and starting with number of cases because that's what they had, N. And then they have, if we go up here, yeah, see, that's where they show their missing data. But SPSS doesn't have that on the list. So what we're going to do now is minimum is next in their output. So I'm going to choose that next. And then maximum. And you see that's on the top line of the output. And then it's just because they didn't have enough room on the page to keep going to the right. So now below that, you'll see mean, which I'm going to go down here because I stuck it down here. Mean, variance, which is right here. Standard deviation, which I stuck down here earlier. And then again, down below that is skewness and kurtosis. So I just chose exactly what they did because they're describing it in SAS, but I have SPSS, so I'm just trying to match it. And I do think we did this right with the independent layers, but we'll see. We're going to go ahead and click continue. Now I'm wondering, I don't remember if they did not click yet test for linearity. We may have to come back and do that, but it might show us that in a different way. So we'll just click continue for now. We followed their instructions. Let's go ahead and click OK and see what the output looks like, see if it matches. Okay, so you see first of all that our data is grouped by religious affiliation and employment status. This first group, it's none or other and employed, and we're going to have 8 different sets of things going down. So, I'm trying to see what this did is, okay, so I did do that wrong. The independence should not have been that way. We really just wanted the straight up variables. So we'll just save this anyway in case we want to come back to it, but let's go back to our data set and try that again, compare means. And clearly we were wrong about this independent layers. And I think we can leave that alone because of the fact that it's already measuring it by the 2 independent variables. So I think where I went wrong was I needed them in the dependent list because ultimately they're covariates, so they're on the same level. So that's where I went wrong. So we need to put over there physical health symptoms, mental health symptoms, use of psychotropic medication. All our options will be the same, so we don't have to do that part again. That's why it's okay if you make a mistake because it's generally not too hard to go back and realize your mistake and fix it. So we'll click OK again, and that should give us what we're looking for. Now, it started me all the way at the bottom of my my output. So I'm going to need to go up and figure out where this one here. So look for your most recent means in your output. That's the one that's going to come out right. And here we have what the book has. this table right here is the replica of what they have listed. And you'll see the minimum, maximum, all that. The variance should be the same. It's rounded here. So it's 1.825 and 58.632, etc. The skewness and kurtosis, which we won't actually need in this assumptions testing, but it's there. They have it, so I put it. They'll reference it, but only to say that it's not important. So that's just part of the learning process they wanted to show us. So you'll see there now I have my 8 groups, the religious affiliation, and I can see my N right here. So this group, there's 30 women who had no religious affiliation and were unemployed. And then there were 63 women who were Catholic and employed, etc. So each group. Now, on page 227 or table 6.13, they created a little table that makes it easy to see the cell sizes, which is basically the size of each group, each of the 8 groups. And so I ended up recreating that table just in Word for my write-up, just to follow along with what the book had and make it look nice. So you can do that. The numbers, as we've done them here, are the same, fortunately, as the book. So we can just copy down that table. There's those 8 group sizes that you can see. All right, so we've figured all of that out. We've gotten rid of the missing data. And so now we have, that's why our group sizes are matching the way they are, because those 3 cases have been eliminated. So now we're going to look for within cell outliers. And this is what we're going to need this output for. So we are, hold on one second. Oh, okay. The reason I'm confused, and this took me like hours before, is that on page 224 or section 6.6 here, it goes from unequal n and missing data, and it kind of jumps ahead to outliers, even though in their little list that we're following, that comes next. They inserted normality and linearity. So let's skip down for a second to 6.6.1.4, where it says outliers. And what we're looking for is any outliers on each of the, the dependent variable and each of the covariates, and that would be the univariate outliers. And they did not mention this, but what I chose to do here, let's save this. What I chose to do to kind of look for this was to do 2 things. First, in the data set here, I'm going to go with analyze descriptives and QQ plots, because that's going to show me univariate outliers kind of visually. So I'm just going to put the dependent variable and the covariates here, because these, remember, are the continuous variables. You're not going to have outliers on categorical variables. That would be the missing data, right? So those are all set, but we just need to see here some plots so that we can just look for outliers real quick, univariate. So I'm going to click OK on this, and then in my output, it's going to take a second because it's a bunch of charts here. Hold on, it's coming. Now remember, it's still analyzing it by the 8 groups, so it will show me these as 8 different QQ plots, or it should. I don't know if we're still waiting here. It should tell me, yep, there we go. Okay. I was getting worried for a second. All right, so here we have the 4 variables that are covariates, or this is the dependent variable. You see here, this attitude towards the use of drugs follows the line real nicely, so there's no univariate outliers on that one. Let's take a look. You can skip the detrended and go to physical health symptoms. Again, this follows the line really carefully, and so that doesn't look like there's any outliers on that variable. The mental health symptoms, pretty close. This might here, maybe, but according to the book, that's not the case. And I'm actually surprised that this physical health symptoms. Oh, I see what I did. Okay, so this is showing us in each of the categories. When I did this on my own, I actually had done this before I figured out how to split them into the 8 categories. So right now, we're actually going to see specifically where the outliers are. What I'm talking you through, if there were just 4 charts, then that would show us. But really, there's 32 charts. There's 4 in each of them. So actually, it'll just show you which group the outliers might be in. So that's fine. But on what I was just talking you through, it makes it seem like we don't have an outlier, and we do for physical health. And you know that because the book says so. So we could either just go back and unsplit our file for a minute, or just say, all right, we'll just take note of any here that might be outliers, and then we'll know kind of what group they're in. So here, the use of psychotropic drugs, I would say we definitely have an outlier at least over here. So jot that down for yourself, that use of psychotropic drugs, there is a univariate outlier, at least one in that one that we found so far. Let's keep looking. That looks okay. I'm just scrolling down through all of our charts because it's going to take a while. That looks like maybe there's an outlier here, and this is physical health symptoms. So go ahead and write down physical health symptoms. That's another variable. So far we have use of psychotropic drugs that had an outlier here, and physical health symptoms. Again, this matches what the book is saying, which those were the 2 variables that had univariate outliers that they found. Mental health symptoms, that looks good. Again, another use of psychotropic drugs might be right here. So we could count that as an outlier. And that's a pretty straight line, even though it's on the edge. And we know from the book that attitude towards medications does not have an outlier. So we're going to trust them on that, and that looks okay. Here you see the outlier is way off the line. So that's, again, physical health symptoms. So I'm not counting. You can go back and count. But there's at least a few univariate outliers here on the use of psychotropic drugs. And so we could note those, what group they're in. But ultimately, we don't need to waste our time because we're going to end up transforming this data. So I'll just give you the heads up, spoiler alert right there. We are not going to do anything about these outliers. The book walks you through your options. So if you find outliers, either univariate or multivariate, you can eliminate them from your data set, or you can try to transform the data. And since it's just, again, another one for the use of psychotropic drugs, since it's just 2 variables so far, we may want to just transform that data. So once you've looked through that, and go ahead and save that output. I don't know if at some point it might crash. I tend to limit the amount that's in one output, so that it's not so big of a file and it might be less likely to crash. I'm not sure if that's true, but that's what I tend to do. It'll automatically save your output every time, or it'll automatically put it in a new file for you. So I'm going to go ahead and close this. And the next time I run something, a new output will appear and we can save it as a different file. Again, maybe that's just superstitious on my part, but I'm going to save the data set as well. See, there we go. My new output has popped up because I hit save. And now I'm going to save this as output to ANCOVA so that I can find it with my other one later. Okay, just little tricks. I don't know if they work, but that's what I do. All right, so now we need to look for multivariate outliers, and this is where I spent hours for nothing. So I'm about to save you like 5 hours of your life right here. So for the multivariate outliers, the process that they talk about that they use in SAS is running a regression, which again just lets us compare the interactions and kind of the predictions so that it shows all the levels of all the different variables. So we want to do that, but and we want to pay attention here to this number that it says critical chi-squared with 3 covariates is 16.266. That's in the section on page 224 labeled 6.6.1.4 about outliers. That value is given to you. So pay attention to that. That is their Mahalanobis distance. I could not get that same number to calculate in SPSS the same way, but we can still use it and hang on to it. It will help us when we're looking for the multivariate outliers. So we are going to use in SPSS just the Mahalanobis distance to look for the multivariate outliers. And if you remember from the data screening exercise, we can actually have the outliers in a chart that we can easily look for the case numbers that would be the problems. So what we're going to do is we're going to run the regression, analyze regression, linear, click on that, and then the dependent variable we can put as this. It's not part of the calculation, and that's what the book talks about, so we know we're doing that right. And the 3 independents, this is why I got confused before. Okay, because in this case, we are putting the covariates as the independents. That is what we're doing. Again, because our research is not about a regression, and so that's why it's confusing. But in this particular case, we want to check for the multivariate outliers on these, and it's going to split our data by the categories that we have. So basically, if you click on statistics here, I think it really doesn't matter because the only thing we really want is, you know what, actually, do we need collinearity? Not for this. We don't need collinearity because we're going to look for that a different way. So I think that the only thing that we actually needed is in this save here. They want you to click on leverage values. SPSS does not calculate the same leverage values that are shown in the book. So you can check off that if you want, and it'll save it as a variable, but it's an unnecessary step because it's not going to help you. And it'll show you these values anyway, even if it doesn't save them. So you don't even need the Mahalanobis distances to be saved. So cancel out of that. Options. Okay. So what we need to do, though, is paste an extra bit of output into this regression to get our little outliers with the Mahalanobis distance showing. So we're going to click paste. And if you remember from what we did last time, let's get rid of the period there because we're going to add another line. You need a slash and then residuals. That's the extra chart. Equals, equals outliers, which pops up for you right there. And then in parentheses, MAHAL, the Mahalanobis. That's what we're going to use, and we're going to compare it to the 16.266 that's calculated in the book. Let's put a period so that it will run it, because that tells us that it is finished. We'll click back up here on regression, and we'll hit this green button to run our selection. And it doesn't automatically pop up your output. That's okay. We just have to minimize this and go over to it. So we'll look for the output too here, and here we are. Here's our regression. Now, ignore everything except for outlier statistics right here. And we're looking for all the cases that are more than 16.266. And so if you scroll down, eventually you will find a number that's bigger than that. So good so far. Let's go back, outliers here. Okay, case 96 is higher. It's 16.312. That is higher than 16.266. Going to keep going here, looking at these outliers. Here's another one, case 160. So jot that down. Keep going. These values are fine. They're low enough. Okay, here's one, case 295. That's a big one there. Again, this is looking for the Mahalanobis distance. That's the distance away from the regression line. And what that tells you, it's almost like the QQ plots in a way, except the regression line factors in all of these variables rather than just looking at one. And that's why it's multivariate. So it's kind of like what we saw when we saw the univariate QQ plots and we saw a little dot way off to the side. It was clearly too far away. That's what the Mahalanobis distance calculates for the regression line. Okay, here we are. This one's fine. No cases here. Keep scrolling down. And the last one here, case 442, is also above our critical value of 16.266. So you should have written down 4 cases. And so there are 4 cases of multivariate outliers, which is what the book says. So then we know that that is correct. So you can kind of skip their description of the critical leverage values because it doesn't calculate that in SPSS. And actually, someone, Ashley pointed out in chapter 7, it actually tells us that. So several of us wasted hours for nothing. Oops, I'm just trying to save the output here. Okay, so now we have a decision, and that's what the book is leading us towards. Should we eliminate those cases or should we transform them, the variables? And so if we looked at where these multivariate outlier cases are located, we would have to figure that out, and I'm not sure here that it necessarily spells it out for us, but yeah, on page 227, it does say altogether 4 cases are multivariate outliers in 4 different groups. And so ultimately what they go on to say is that the 2 variables where we have the outliers are still the use of psychotropic medications or drugs and the physical health. And so we're going to go ahead and just move along with that information and decide to go along with the book and say, okay, even though I'm not sure that the outliers tell us exactly what, like where that was an outlier on, it's a multivariate outlier. I think what we're looking for is, does that get fixed if we change? That's what it is. Now I understand it. Okay, I'm just understanding this right now. I did the whole assignment. Basically, if we change or transform the 2 variables where we had the univariate outliers, then we might be able to see if this Mahalanobis distance gets under control and then we don't have multivariate outliers anymore, or if it doesn't fix it. And then we might be more likely to eliminate those 4 cases we wrote down. So let us close or minimize the output, and we will do a logarithmic transformation. I've been at this a while, guys, to transform those 2 variables. And so we're going to go to transform and compute variable. And our target variable is what we're naming the new one. And we're going to just follow what the book says so that we're consistent. It's LPSY drug. So the L just reminds you that this variable is the logarithmic transformation. And then if you recall from the data screening assignment when we transform variables, the formula is LG10, because that's a base 10. That's like most of our number system is base 10. And we're going to do, okay, this is psi drug, so use of psychotropic medications is here. I'm just going to make sure that's exactly right. Then we have to do +1, so we don't get any, there's no values of 0 that it's trying to calculate a log from. And then that's it. So we go ahead and click OK. And nothing too fancy happens in our output. It just says, yep, I computed that. But what's really exciting is if we go to our data set, we have a brand new variable, L psi drug. And you can see there that these cases are still eliminated anyway, so we don't have to worry about that. There are values of 0 in the end of the logarithmic transformation. That's fine. The reason we added +1 was so that it didn't try to calculate on an existing 0. And so I was wondering about that, but then I figured it out. Okay, so now we're going to do that one more time for the other problematic univariate outlier variable. And so we're going to do transform, compute variable, and now we're going to name this one LPHYHEAL to match the book. And we're going to erase this, keep the LG10 there, but now it's going to be physical health +1, close that parentheses, and click OK. Once again, boring little output, but we have a new variable, LPHYHEAL, physical health. So now what we can do is run that regression again. Let's save this data set with our new variables so we don't lose them. Analyze, go down to regression, linear, and we're going to get rid of physical health symptoms and use of psychotropic drugs because we no longer have those. We're not using those variables anymore. We're using the transformed variables. So we're moving the L psych drug and L physical health over here. Same thing. I don't think we might want to, yeah, I ended up using the collinearity diagnostics later. So I'm going to go ahead and click on that now because I'm going to need them later. So let's click on collinearity diagnostics. If you missed that, what I just did was I clicked on statistics. Then I'm going to click on collinearity diagnostics. I don't need the descriptives. I've already got that. I don't need any of these things. So that is all I'm going to need. Continue. I don't need any plots because, again, we're going to talk about normality in a minute, but we don't need normality on the scores of the data. We just need it in the sample, and so we don't need that data. We don't need to save anything. What are our options? Yeah, we don't need any of that. So, yep, that's all we need, just the collinearity diagnostics, and we'll click OK. And now we're going to do that same thing. We're going to have to try to find the beginning of this regression here. It should be where the employed non-religiously affiliated group is. So we'll just scroll up till we find it. Here we go. This is our latest regression. And you can just tell that it's with our new variables because you can see in the syntax. So I know I'm looking at the correct one and I'm not confused. Sometimes if you scroll through this syntax, this output, you get a little lost because there's so much of it. So now we're just, again, looking for our, oh, you know what? I did this to myself when I did it too. We forgot when we ran the regression again that we needed to paste that output with the outliers to get that Mahalanobis distance table so we could compare. I did that exactly last time too. So you're seeing the mistakes that I made, and it took me millions of years to figure out how to fix those things. So I'm saving you so much time. All right, analyze regression, linear, here we go. And all of this is the same, and the statistics are still going to have that because it saves that So we're good to go, but what we need to do instead of hitting OK is hit paste, and then it won't pop up. You'll just still have your syntax editor that you can find at the bottom of your screen. What we need to do is take this line and add it just like we did the last time. So get rid of that period at the end of this one. We need to use this one because it has the new variables right here. So the L psi drug and the L physical health. We're getting rid of that period, hit enter, paste that new command, and actually I think it put a little extra space in there, which I'm not sure if that matters, but get it right. And the period is there, so our formula should be good to go. We got to click back up on regression to be in the right spot where we want to run it. Okay, now this is going to be running our new regression with the transform variables, with our outlier tables, and we'll see if any of these values are above 16.266. Here we go. Now, again, you hit run, you think nothing happened, just minimize this and go to your output. I don't know why the syntax editor doesn't pop it up automatically, but here we are at the end of our output, and yay, we have our outlier statistics now. So let us go back all the way up to the top of this one. You can see why I save multiple output files, because they're so gigantic. They're a little unwieldy. All right, so here we are, and this is the top of our regression, and again, here's the syntax that reminds us, yep, we're looking at the right one, because it has our transform variables and our residuals, Mahalanobis, right there. So here we go. We're looking we're going to come back to the collinearity diagnostics later, but right now we're just looking at the outlier statistics. So, okay, that's less than 16.266. Let's go down here. Yep, less. Scooting down. Yep, that's less. Okay, yep, less. Looks good. Okay, that one looks good too. We're getting there. Okay, that looks good. I think this is our last one. Okay, so now we see that all of them are no longer multivariate outliers, and we could go back and do some QQ plots. You know what? Let's do it. Let's take the time. You don't have anything else to do, I'm sure, just like I have not had anything else to do for the whole last day and a half. Wow, sarcasm, it's coming in, guys. It really starts getting to you. Let's unsplit the file for a second. Click on Analyze All Cases. Sorry, I'm moving too fast here. Let me cancel that. I clicked on Data. I clicked on Split File. I am clicking on Analyze All Cases, please, because what I want is just two really beautiful QQ plots so that I can include them in my assignment to show that the outliers are fixed. So I'm going to click OK. And now I'm gonna hit save on my output just because I'm thinking of it. I am going to go ahead and analyze Descriptive Statistics, QQ plots. And now all I want is the new transform variables. So I'm gonna, if you hit Shift, it selects all of them. And then you have to click on one, hold down Shift while you're clicking that one. Then you can scoot them all at once. And we just want this one and this one. These are our new transform variables. And we just want to see. Now this, I notice it says, by the way, natural log transform. And I'm not sure if that is something we could click on when we first do our QQ plots to kind of see if that helps. But I've never clicked on that, and you could play around with that if you want. But right now we're going to click OK. And in our output, we are going to see just, again, this univariate variable now, and it looks better. You know what we could do to compare, because last time we had the split file on, we couldn't see the QQ plots just by the one variable without it being broken. So we had like 8 different charts. For the sake of your assignment, if you are wanting to put in some charts, you can put in this one, which is a transformed variable, And this one here, which looks so nice, transform variable. Let's save that. What I do, by the way, is I just screenshot and then crop the photo to be the beautiful chart that I want. So that's my method for how I get it into Word in my assignment. So while I don't have the split file on, I am going to make QQ plots of the old psych drugs and physical health one. So physical health symptoms, use of psychotropic drugs. Again, we transform these. This is just to show what our transformation did. So let's go ahead and click OK on that. And here at the bottom of the output, you'll see this is the old one. And this is what it looked like. So all in one chart instead of 8 charts, you can see there's some outliers here. And here, oh my goodness, this is horrible. This one has some definite outliers here. So that would be your evidence that you needed to transform the variables. And then up above, what we just did with the transform variables would show that it's changed. So that's a nice contrast to include that, okay, wow, that's a lot better than it was before, and it looks like we're good to go. So our data transformation helped, and that is the within cell outliers section. That is the longest section, so now we're going to scoot right along, and it'll be much better after this. So here we go. We are now going to go to normality. And great news, we don't have to do anything, because what the book explains, both on page 224 in the little section 6.6.1.2 on normality, it says that the normality applies to the sampling distribution of means, not to the raw scores. So the skewness, even though we saw it earlier, doesn't pose a problem. Also, if you flip back earlier in the chapter on page 202, in the section 6.3.2.4, it also says that the sampling distribution is of the sample, not the raw scores. And it says, without knowledge of population values or production of actual sampling distributions of means, there's no way to test this assumption. However, the central limit theorem suggests that with large sample sizes, sampling distributions are normal, even if raw scores are not. So because we have relatively equal sample sizes in our groups, we now don't have any outliers. For a two-tailed test and less than 20 degrees of freedom, we are good. So you could just write that up and quote those things and say that we're going to assume that this is a normal population, it's a normal sample. There's no way we can go back to 1975 and find that out. So we're going to move on then to homogeneity of variance. And what we're going to do is we're going to look at, we're going to first actually hit save. We're going to split our file back into the 8 groups. So all we need to do is just click organize by group. It saved for us. So we'll just click OK. And then minimize that output. Okay, so now we can look for homogeneity of variance, and we're going to do the compare means again using the new transformed variables. And the only things we need to look at are sample size, means, and variances. So we'll go over here to analyze, compare means, means. And this dependent list, now we're going to get rid of use of psychotropic drugs and physical health symptoms. We're going to keep the other 2 in there, and we're just going to go here and add in our new transformed variables. And under options, we can actually get rid of everything except for, like I said, the sample size, the means, and the variances, because that is what their output shows on, trying to see where their output is on that. Okay, it's on page 228 in the 5th edition. we're on to the section 6.6.1.6. So the output is actually on page 229 on the next page. It's table 6.17, sample sizes, means, and variances for transform variables. And so you can see their list of all four of these, the dependent variable and the covariates. And you can see they did this one. Again, they're just showing you one of them, the religious affiliation and the employment status. You're going to have 8 of these, but we can get rid of these extra bits of data that will just make it harder to see. So we're getting rid of the minimum, maximum. So we want number of cases, mean, variance, and we can get rid of everything else. And then we click continue. Now, again, I'm tempted to click on test for linearity because we're going to need that next, but it actually, we don't need that. So we're going to be looking at the collinearity diagnostics that we already got when we did the regression. That's what we'll go back to. So don't worry. I see things sometimes and I think, oh no, should I click on that? But in this case, I didn't. Okay. So let me just make sure. Yeah, this is still recording. Good. All right. Didn't want to mess that up. Okay, so we're going to click OK. And again, this is just going to give us the output that they have in table 6.17. Click OK here. And here is, we're looking for the homogeneity of variance. So what they describe to do is basically to look for the lowest or smallest variance and then also the highest variance. And they tell you which groups they're in, so if you want to look specifically, you can, but we'll just go ahead and go all the way up to the beginning to where it says means, because this is where we started. Let's save our output again. All right, so we're going to just take note of the variances, and we know that they're saying here the smallest variance is 0.968, and that is in the Catholic group that's employed. So we could double check ourselves, and what we're looking for here is the variance right here. You see it's third in this table. And so actually this one that I just highlighted, it's in the no religion and employed section. That's actually the largest value, and they say that in the book. That's the 1.825 they're talking about. And we could, again, check all of these, look right here, but we already know that the employed Catholics are right here. So here is the variance that's the smallest, 0.968. And so in your write-up, you could include those two charts, or you could just describe it as they have. But it says that the variance ratio, the criterion is a 10-to-1 ratio. And they do the little calculation for you, but you can obviously tell that if you put the largest one, 1.825, and you divide that by the 0.968, then your ratio is just fine. You don't even have to do the calculation to see that. It's clearly not 10-to-1. So we're good, and we don't need to do any kind of formal test for homogeneity of variance because the sample size, it says the ratio of sample sizes is less than 4-to-1. And they show here that the biggest group that we have is 92. That is the employed Protestant group. The smallest group we have is 30. It's the no religious affiliation that is unemployed. That group is 30. But even, again, simple thinking about it in your head, 92 over 30 is not 4-to-1. So we're good on that. And so we're just going to do what the book recommends and say that this homogeneity of variance is met. So we're going to keep on going. Also, I have one note here that I learned when I did it the first time, is that when we do the ANCOVA, we're actually going to get the Levene's test, and that's a statistic that tells us the homogeneity of variance. And we get that in the output no matter what. We don't even have to click on it. And I will tell you, just spoiler alert, that it's not significant, and that's good. If we had a significant Levene's test, we would not have homogeneity of variance, and that would be a problem. But when we get there, you'll end up seeing that checks out as well. So that's just a double check. So now we're going to move on to within cell linearity. And good news, we already did this. We just have to find it. So here we are in our output, and we want to look for that new regression that we did when we had the collinearity diagnostics, and we did it on the transformed variables. So let's just go up and find where that is. I think it should be right here. When you get to the outlier statistics, you'll see here. And so, yep, there's our collinearity diagnostics. All right, we're at the bottom, so we might as well go backwards through our groups here. I think it's Jewish unemployed is the lowest group, so we'll just go up instead of down this time. And you see here the condition index. Now, if you recall from the data screening exercise that we did, that has to be lower than 30. And if anything is approaching 30, we want to check the row and make sure it doesn't have, in these variables here, it doesn't have any that are more than 0.5. You can't have two of those in one row. Then you'd have more than 100. So that would be a problem. You can't have it higher than 1. That's the point of the collinearity. And so, yeah, we can check here in these condition index and just make sure that nothing's approaching 30. And if it is, we'll check the row. But again, spoiler alert, it's fine. So you can go through and glance at every single one. You'll have 8 of these collinearity diagnostics. I did a little screenshot, and for each of these little collinearity tables, I put all 8 of them into my assignment just to show that the condition index is fine and show the raw data there. So again, we can keep just scrolling up. Yep, that looks good. Nothing close to 30. Here we go. Here's another one. Nothing close. Okay. Again, we're good here. This one looks good too. And we're still scrolling up here. We're almost done. This one's fine. And the last group here is really the top one. The first one is religion, none, and employed. And here's our final one. The condition index looks good. So we have within cell linearity. And the within cell is just within the group. Each of the 8 groups is a little cell in our table that we had made before. And so all of those are within range, and we're good. Now, the homogeneity of regression, we actually are going to run that when we are running our interaction effects, ANCOVA. And so we can just come back to that in a second, because the last thing that we need before we start our main analysis is just a little note about the reliability of the covariates. And this is explained in section 6.6.1.8, reliability of covariates. On mine, it's page 230. And it explains that basically we're trying to figure out if those covariates, like how reliable, is that data. And the question that the participants were asked for each of those categories was, have you ever, maybe experienced a certain kind of mental health problem or physical health problem? Or have you ever taken psychotropic medication, or how often, those kinds of things. So it was those values that we have for those variables it's just a count. It's like the number of times, the number of mental health problems they said yes to, the number of physical health problems they said yes to, the number of times they took the psychotropic drugs. And so in that, they are basically saying that it's unlikely that someone would answer one way, and then if you ask them later on that same day, they might answer a different way. They either have experienced that or they haven't. And other than the passage of time where that could change what they've experienced, like they're not going to change their mind about it. It's either happened or it hasn't happened. And most likely they're not going to be confused by that. They're going to give a reliable answer. So we can go ahead and just state that, and we can say that the covariates are reliable because of the way that the survey was laid out. Again, we've got to take the book's word for that because we weren't there, but they give us that. So let us now, we're going to still wait and come back to the homogeneity regression later. We're going to do that in a minute. The first thing now we're ready for is our main analysis. And so I have written myself a note that says, be sure the file is no longer split. So I'm going to go ahead and go data, split file, analyze all cases. Because now we're going to be using the independent variables of religious affiliation and current employment. And so we don't want it to separate it based on that. We want to see all the cases together. So we're going to click OK and minimize our output again here. Let's save the data set. Now what we're going to do is analyze, and we're going to use a general linear model. That's the GLM that they talk about. Again, they're giving the instructions for the SAS software package, and so we're using SPSS. It's slightly different. So this is why I'm showing you the steps. So general linear model, univariate. If it was multivariate, it would be a MANCOVA, by the way, not a man cave, a MANCOVA. All you people that made it all the way through this video so far are laughing right now at that joke, so you're welcome. All right, our dependent variable, as you know, is the attitude towards the use of medications. Our fixed factors, those are our independent variables, so we're going to put religion first because that's what the book does. I don't know if that order matters, but I'm going to just follow their instructions. We don't have random factors, but we do have covariates. And please make sure you use the transform data for the covariates, or your assumptions testing will no longer be valid and you will have wasted all that time. We do need the mental health symptoms as well. That's our third covariate. Now, here's where it gets a little tricky. This main analysis that we're first going to do is going to be type 1. So if you click on model, this sum of squares, type 3 is the default setting. You have to click on type 1. And this is explained in their table 6.10, which was earlier in the chapter on page 218. It talks about these different research types, and ultimately, because they want the data to be weighted based on the cell size to kind of compensate for the fact that we don't have exactly equal groups, they want us to do this type 1. And so that's method 3 that they're talking about. So you can read more around that section about why they chose to do that. But it ultimately seems to compensate for unequal group sizes. So I'm going to go ahead and click continue. We're going to run this again and do a type 3 in a minute, and that's what's going to get us back to our homogeneity of regression. But for now, we're clicking type 1. And then we are, let me see, EM means. I think we might want to display the means for religion, employment, and the interaction effect. We can click on compare main effects, continue. Let me see what else I wrote down here, what else I did. Okay. I clicked on a couple other things, I think in the options. Yep, options. Estimates of effect size, because we're going to need that later. And then I think I did homogeneity tests, but we can click on that. I don't think we need to do that. I think in the end I learned a different way to do it, but we'll see. Maybe I'll learn it a different way again. Okay, I'm just looking at my notes here to see anything else. Okay, that should be it. So I'm going to go ahead and click OK. And here we are in our output. Hit save. Okay. So now, here we go, by the way. This is our Levine's test, which just automatically pops up for us. And you'll see the significance here is not significant. That's good. So that means we do have the homogeneity of variance, which we already knew, but just in case you were worried. All right, and so here is our first table that we're going to be looking at to understand what exactly is the answer to our research question. Remember, we wanted to know if religious affiliation or employment status has anything to do with a person's attitude towards their use of medications. This study was all women, so we know that already just from the book. And so what we want to look for is significant values on just right now. We're only going to look at religion, employment, and the interaction effect right here. These three. We're going to run it again to look at the interaction effect. So I guess in some ways, maybe we didn't need to click on these, but I'm not sure. I just tried to follow what the book said. So here we are anyway. We've gotten this religion, employment, and religion, employment. Now, 0.05 is significance, and we have here religion, 0.037. So that is significant. Employment, however, is not significant, and neither is the interaction effect. So there you have it. Isn't that interesting? And perhaps not surprising that a religious affiliation would have something to do, some kind of relationship. We can't say it causes it, but it has some kind of relationship with what your attitude toward medication would be. We don't know exactly where the interaction is yet, like which religion. We're going to get to that in our kind of post hoc comparisons. But right now, we just know that religion is a factor in attitudes toward medication, but employment and religion employment are not. So you could write that up similar to how they have that in the book. Here's our pairwise comparisons. And this is where we're going to actually come back to this chart to look for where are the differences. But right now, we'll just kind of show you here, this is significant. The difference between the Catholics and the people who have no religious preference, that's a significant difference. And we can tell because it's negative, and you can see down here in the same comparison, it's positive, that means being Catholic, they have a higher or more favorable view of the use of medications than does the no religious affiliation. So we actually can look at that up here. Religious affiliation, this is the estimates of the means, and we see here that the highest mean for the attitude towards the use of drugs is the Catholic group, and then we see here Protestant and Jewish are kind of in the middle, and the least favorable attitudes, or the lowest mean scores on that attitudes scale, was the no religious affiliation. And so that tells us kind of the order of the groups and who thinks, kind of how we would rank them. Now let's go back down here for a second, see if anything else is significant. Of course, you're going to see doubles because it kind of, each comparison is done twice depending on where it is in the chart. Here it's Catholic and none or other. Here it's none or other Catholic. That's the same comparison, just listed in a different spot. So don't count that as two significant things, but we do have here this 0.002. Those are not significant, but here we have 0.05, the difference between the Protestant and Catholic view. And so let's see, do we have anything else? And then that's the same 0.05, and that's it. So that's your main, no, sorry, that's not your main comparison. That's going to be your post hoc comparison. And so you can talk about that later on if you want. In our assignment, that's a later section. So that you can post those charts, not in the main effects, but in the after effects. And let me see, do we need anything else? Oh, partial eta squared. Okay, so you're going to need to look at this. Again, this chart, we're only looking at these three numbers here. Partial eta squared is what measures the effect size. And so the book talks about this. They round up. So if you're confused why this says 0.019 and they're talking about 0.02, they're just rounding because that's APA style to do 2 decimal places. So 0.02, and this one is 0.01, and this is 0.02. Those are considered weak effects. So when you talk about there's a section that we have to do about effect sizes. That's these three numbers is what you need. And the book tells you that the confidence interval is 95%, which is true for all of this. And their upper bound and lower bound, I am still not entirely sure where they got that. So I can't tell you in our output where that is, but if you go by what the book says, let me see. On page, where does it talk about effect size? Sorry, maybe you're already finding it and shouting it out to me, but I can't hear you. Here we are, page 232 for me in the 5th edition. It's right underneath an equation that says partial eta squared, which is a little symbol of a cursive N type of looking thing. And it talks about that. So it says that the confidence intervals, oh, I see, they have a different file that they used. So we don't need to do all that. We just need to, in our write-up, say that it was a 95% confidence interval. And for, I see, this is just standard values in the procedure. So for religion, it ranges from 0.00 to 0.04. The effect size for employment status, which is at 0.01 number up here, right there, if you round, 0.01. That's a 95% confidence interval ranging from 0.00 to 0.03. And the interaction effect is, again, 0.02, also with a 95% confidence interval ranging from 0.00 to 0.04. So as the book explains, these are considered weak effects, and in fact, the only one that was significant anyway was religion, but 0.02 is not really a strong effect. So it's a relationship is there, but we'd have to do more research to figure out, what that's really about. Okay, so that is our main analysis, is those three things, because that was the original question we had. So religion, employment, and the interaction effect, and that gives us a little bit of a conclusion with that significance there. So now we're going to minimize this output. We're going to go back to our data set, and we're going to run a second ANCOVA, which again, we click Analyze, General Linear Model, Univariate. And this time in our model, we are going to select type 3. Now, in this one, because we want to use it to go back for our homogeneity of regression, what we need to do, and this is described in section 6.6.2.3, I actually found it on a Todd Grande video as well, which explained it better because they don't give you the SPSS instructions here. And so you see what they're talking about, that they want all of these comparisons. So they want basically every type of comparison you can make. They want to see that. What you have to do is click on Build Terms, and you can see in table 6.25, which is for me on page 237, that it's the syntax and the output. That gives us the order of things that we're going to do. So if you see on the left there where it says source, the first thing listed is religion. We're going to put that over here. That's the first model. Then we're going to look at employment. Then we're going to look at the interaction between religion and employment. So what you have to do is click on the control button. First here, click employment. Then click on the control button while you're selecting the other one. So it selects 2 of them. Move that over. You see how it does that there. It does not matter which order it's listed in. So even though in the book it says religion and employment, this says employment and religion, it's the same interaction, so that doesn't matter. Now we want to go down here to, again, we're just following the column on the left, L, physical health, then L, physical health with religion. So again, hit that control button and select both of them. Hop that over there. Same thing now for employment. And now we want the interaction of physical health and religion and employment. So we're going to hit control when we select employment and also religion. Keep holding it down and then scoot that over. Now we're looking at the psych drugs and religion. And psych drugs, religion, and employment. Just hold down control, stick it over there. Now we've got mental health. And then we've got mental health and religion. Mental health and employment. And mental health with religion and employment. Okay, and that list should match the output that they have in the book, even though they did it a slightly different way. And maybe in SPSS we could do a custom syntax as well, but this was the way that Todd Grande showed me how to do it, and I appreciate that. So that's what I did. And so this is going to tell us the homogeneity of regression. Remember, that's basically looking for all the regression lines to be mostly parallel. And we're not going to see a chart of that, but we can look for some specific numbers to see that. So we're going to go ahead and now continue, and we're going to click OK. Okay, don't worry about these warnings here. It's just we're redundant on some of the things, and so it's just not showing us things we already have. So we're going to go down here, and we have a new chart. Remember, we had the chart earlier where we got our main analysis from way up here. And we were just looking at religion, employment, and religion and employment. Now we're looking at the interaction effect. So we want to know, is there any covariates that are also kind of have some type of relationship or aligned with our dependent variable. So you see here, our dependent variable was still attitude towards the use of drugs. And now it's going to show us the significance, all of this here. We're going to figure out if there's anything, if religion and employment, we already had looked at that. We're going to look at the interaction of each of the three covariates. So we really want kind of this information down here for our interaction effect. I'm looking at, there might have been one other thing that I did. So let me back up, because right now we can talk about the homogeneity of regression. And ultimately, the book had something that my output chart did not. But yes, okay, now I understand what I'm thinking. Okay, so this is the last test we need to run. And so what we can look at is the interaction effects for all of the covariates in every way. And so let's just start. I'm sorry if I'm confusing you. I'm just remembering myself what this all means. Let's just look at the significance column for a second and see if anything is significant and then move on from there. So nothing, 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 nothing until you get down here. L-Psy drug, which is the psychotropic medications, that is significant, and the book mentions that as well. So what that means for that one is that we also know that the attitudes towards the use of medications has a relationship to the variable use of psychotropic medications. Now that makes sense. If you have a good view of medications, you'll take them. So perhaps not surprising that the people who are taking the drugs, that is related to their attitude toward the drugs. So that is significant. And in your write-up on interaction effects or planned comparisons, you would put that one. Otherwise, we don't have anything significant here. And in the write-up on the homogeneity of regression, that is what I'm trying to remember. Let me look at mine to see what I explained, because I forget what we're looking at here. So let me just scoot down to my thing here. Okay. I think that what we're seeing is that there's no significant interaction effects for the covariates and the independent variables. So basically, the covariate with religion, employment, and the combination, not significant. We see that this covariate is significant, but it's not significant with religion, employment, or the combination of employment. Did we miss that one? We might have missed one because I'm not seeing the employment by psych drugs. So we might have somehow missed that in our little interaction list we were making. You could go back and rerun that because they should all still be there. But so if you want to do that for to have a chart that has everything complete, that might be a good idea. We'll do that in a second. Sorry to have missed that. But what we want on each of them is religion, employment, and the interaction effect. Essentially what this is saying, let's say there was significance on any of these covariates for the interaction with religion, employment, or religion and employment. What that would signal is that perhaps one of our covariates is too closely aligned with our dependent variable. And so that might be that we're not actually measuring something correctly with this ANCOVA. But because there is no significance that means that we're definitely measuring something different with the covariates than we are with the dependent variable. And so that's the homogeneity of regression. And so that assumption is met. The book did find some slight significance on psych, drug, religion, and employment combined here. I'm not sure why we have slightly different values on that, but ultimately ours are not significant and theirs they decided not to count, so we're good. Let's just, for the sake of it, so you have the right, most beautiful chart possible for your assignment, is to go back to analyze, general linear model, univariate. Let's go over here to our model. See, it saved it all for us. But you see here, what we did do is we did miss this L, psych, drug, and employment. Maybe while I was doing it, you caught it and you were shouting to me, please, Kristen, choose that one, and I didn't hear you. Because that's how videos work, guys. And also, you'll start making really dumb jokes after you've been doing this for hours and hours. So hopefully this is saving you time. So let's add that interaction of L, psych, drug, and employment that we missed the first time. Let's scoot it in there. Now, it's going to be way down here, and I don't know. Can I drag that up? Yeah, maybe I can. All right, because I want it with the other psych drug ones. Yay! Okay, so there you have it. We missed one, but not all is lost. There is still hope in the world. We'll click OK. Our warnings, because we're doing this multiple times, that's fine. Here we have our correct chart, which we could include in our assignment. And here we just double check employment, psych drug. Yep, also not significant. Oh, maybe that's why they got, now our numbers are matching the book. Maybe I did that the last time too. So psych, drug, and religion and employment is approaching significance. They say 0.05, which if you round, that's true. Suggesting that there are different relationships between the attitudes towards medication and the use of the psychotropic medications among the 8 groups of women. So it's possible that on that interaction effect, there's some split among the 8 groups. But in this case, they're saying that that's kind of not too stringent of a criteria, so they recommend not worrying about it. So there you have it. That solved our problem, and that's it. So now we talked about the main analysis that we did, where we looked just at that type 1 output, the first ANCOVA that we ran. Then we talked about the interaction, which was this. And the only thing that was significant for the covariate interaction was with the use of medications. That was significant. So we could put that in the interactions. There weren't any planned comparisons because we don't have really any reason to have any other hypothesis. We didn't have any other hypothesis about like how religion or how employment would impact things. Like, okay, you know, what we saw with the differences in Catholic or Protestant, you know, etc. We didn't plan for that. We're not looking for that. That was kind of our post hoc comparison, just because we found significance on the independent variable of religion. So in the assignment, you should have the main effect, put the chart that we very first got, which was in the type 1. So we have to go all the way back. Not that far. Hold on. This was the means. Okay, this is our first analysis of variance, type 1. Here it is. So this little chart you should put in the main analysis section. And then the interactions analysis, you should put this last one that we got. Is that not as far down? Okay. This last one that we got here, this is your interaction comparison, where you can take note of this one level of significance. You can also put this chart or reference it when you write about the homogeneity of regression section, and you can look for guidance on that in the book in that section on how to write that up. And then the effect sizes we covered in the partial eta squared. Again, that was in our other chart, so you'd want to reference your main analysis. And this partial eta squared here, just these three that we looked at, that is in that section of the assignment. And we already went through that, so you can put that in that section. And then the post hoc comparison is where you can put these pairwise comparisons. And you can note the significant values here and here. Oh, sorry, that's lower bound, upper bound. I'm sorry. Here, this 0.002, and here, this 0.05. You can point those out, and you can also include the estimates table here on religious affiliation. And that only matters because we found significance between the dependent variable and the independent variable of religious affiliation. If we had found significance with employment, then we would maybe want to do a pairwise comparison of that. Or if there was an interaction effect, we would want to understand where it is. But that's the post hoc comparison. There were a couple other things that the book mentioned that you could do for post hoc comparisons or additional analyses. The evaluation of covariate effects, which we did, I think, in the interaction, so I didn't do that. Evaluation of intercorrelations, again, you kind of have that information because of the second one that we ran, the type 3 one, so you could include some of that data to look at, where was it? All the way down here at the bottom where we had our complete chart. It was this one here. We had all the interaction effect. You could talk about that and analyze that a little bit, but again, nothing was significant except for this. So there's not really a lot to evaluate about intercorrelations there. But if we had found something, even on this one, we could talk about that, but the book dismisses that. So, and then the unadjusted marginal and or cell means. So I think that says if there's a significant main effect, if it's a non-experimental application, which this is not an experiment, seems like a survey, but I would go all the way back to your very first one. Sorry if my screen is dizzying. Up to the very first one, which we know is the type 1, so that's how we know we got to the first one. Right here, the unadjusted marginal means, again, that's the estimated marginal means. Maybe that's adjusted. Here's the means. And so the covariates are kind of pulled out of that, or they show right here how they would be. I don't know if that means we could test that a different way. I did not do that, and so I'm not sure how to tell you to do that. So you can play around with that if you want, but I think ultimately these are the kind of additional analyses that we can talk about. So there you have it. All right, so then basically we talked about the interaction effect between when we did our pairwise comparisons of Catholic and no religious affiliation and Catholic and Protestant. those two significant numbers. So you can just note that. And we really can't draw any conclusions about that. We would need to do further research to find out why it is that those with no religious affiliation would have a slightly less favorable view or attitude towards medication. We have no idea why that would be. And so if you're taking qualitative research as well, then you could just go interview some people maybe and start there, do a grounded theory approach. There you go. That brings it full circle for us, and we're done. So then you just follow the example of the results write-up that they have on page 238 and 239 in my book, which is the end of chapter 6.6, that section. And then you're good to go. So hope that was helpful, and thanks for watching.